Hello, my name is Heider Delgado, and I'm going to present my IBM Coursera Advanced Data Science Capstone project. My project consists in the New York City dataset, and I'm going to explore and predict what the agency is and what behavior it has. So my dataset is the New York City jobs, categorical data that describes jobs positions in New York. Initially, I had 943 rows and 30 columns. This dataset contains current job postings available on the City of New York's official job site. And my use case is learn the behavior of the data and make predictions on agencies or job titles according to the job posted. And the solutions for my use case were deep neural networks with Keras and Keras with PCA, PySpark, logistic multinomial regression, decision trees classifier, random forest classifier, and I also used some algorithmic clustering. At the end, I chose logistic multinomial regression for my model. For data exploration, I utilized an IBM Watson. Data types, most of my data was categorical or just text. There were some numbers, but most of it was only text that I have to feature engineer. An initial data exploration, I got that the most common agency where job vacancies exist are New York City House Authority with 17.1%, Department of Health and Hygiene with 8.6%, Admin for Children SBC with 8.0%, and I use most of the other data that is not here for 44.4%. Career level requirement. This denotes the career level requirement for the job in New York City. Experienced manager with 70.6%, manager with 16.6%, entry level. That means that you don't have to have experience with 8.2%, and student with 1.4%, executive with 3.3%. Job category to occupation group in which the posted job belongs. Most was technology, data, and innovation with 50.0%, finance and accounting and procurement with 8.2%, and so on. And also there was a lot of job categories that weren't in this 5, so I just put in delivered orders with 55.2%. For data extraction, I also utilized IBM Watson. I used the Soda API to get the data, but when I was doing future engineering and model, I saw that I have too few rows, so I decided to use another data set that is very similar to the original one, but with even more rows and less columns. This one was obtained from data.world, and it has pretty much the same name and is fairly similar. I used Google Colab to do this at the end because I run out of time in IBM Watson. So for feature engineering, I used Google Colab. This was the data that I got from data.world. That is very similar to the original data that I have, but with even more rows and less columns, 4 less columns. To transform the data, one thing that I noticed was that job ID was duplicated a lot. But if I drop it to duplicates, my data will be almost severed in half. I changed most of the categorical data like this, that have a lot of variance at least, to others, and then the biggest ones in this data was the Department of Health and Mental Hygiene, Department for Environment Protection, Department of Info and Text Telecommunication, Admin and Children's SBC, Housing Development, and Department of Design and Construction. These were the labels that I later tried to predict. Most of this data was actually from 2010, I guess, until 2016. Majority of the data had data mostly from 2020, but this has data from 2016. And this was my final data set when I dropped some of the columns that have a lot of missing values, or that had low variances, or that had just text that couldn't be converted to categorical data. I used also a correlation matrix to see if the data that is really similar correlated can be dropped and have a less columns data set. At the end, when I use 100 content to my categorical data, this is the end result data that I have, with 4,190 still rows and with 26 columns. Although when I drop the job ID, because it's only a label, I ended with 25 columns. I used agglomerative clustering to see some clusters, but I didn't really find anything useful here. I found some clusters that were well defined a little, but some of it was just two together. This is a 3D representation of it. For model definition, I use Keras and PySpark. For Keras, I used a deep neural network, and I had a lot of overfitting. That's why I had all these regularizers and dropout. And at the end, with the test and validation data, I got a 0.72 to predict the agency accuracy, which it's not that good, but it's a lot better than what I had previously, when I only had like 60% accuracy with my original data set of only 900 columns. So I had an improvement of 12%. At the end, I tried to use also PySpark, logistic regression, decision tree classifier, and random forest classifier. Here are the confusion matrix for every one of these models, different models. The accuracy is fairly similar, but I decided to choose the best one, which was logistic regression. But I feel like you can use any model, even the deep one. But I decided to choose logistic regression because of all the 4 models that I tried. Even with Keras PCA, that was at least a 5 model, logistic regression was the best performance overall. These are the meanings of the labels here. 6 is for the other columns. The count is my test data, and this is pretty much it. Yeah, this is my final model that I use. I use a PySpark logistic regression for multinomial to predict the agency column. I predicted with an accuracy of 72.9%, which can be then rounded to 73% almost. I guess you can do better, but it's really hard how you feature engineer the data so you can have better categorical values. So this is it. Thank you, and hope it gets approved.